Our next problem, examine convergent or divergent of the following problem. Integral 0 to infinity dx by e raised to x plus 1. Use comparison test. We know that e raised to x plus 1 is greater than or equal to e raised to x. For all x greater than or equal to 0. This inequality, all of you know about this inequality. E raised to x plus 1 is always greater than or equal to e raised to x. You can take inverse 1 by e raised to x plus 1 by e raised to x. So this inequality is also reversed. 1 by e raised to x plus 1 less than or equal to 1 by e raised to x for all x greater than or equal to 0. So we get an inequality 1 by e raised to x plus 1 less than or equal to 1 by e raised to x. So by comparison test, we need f of x and g of x. So we take f of x equal to 1 by e raised to x plus 1 and g of x equal to 1 by e raised to x. Here we get mod f of x less than or equal to mod g of x. So by use comparison test, we can say if integral 0 to infinity g of x is 1 by e raised to x dx is convergent, then integral 0 to infinity 1 by e raised to x plus 1 dx is convergent. So if 0 to infinity 1 by e raised to x, our larger function is convergent, then we get the smaller function is obviously convergent. So we only prove that here, we only prove that integral 0 to infinity 1 by e raised to x dx is convergent. That means integral 0 to infinity e raised to dx is finite. Integral 0 to infinity 1 by e raised to x dx equal to, used by our definition, limit a tends to infinity, integral 0 to a 1 by e raised to x dx. So this upper limit and lower limit are finite. So we can integrate this value, limit a tends to infinity, e raised to minus x divided by minus 1. E raised to minus x integral, e raised to minus x is e raised to minus x by minus 1, 0 to a. That is equal to, you can apply upper limit and lower limit. You get e raised to minus a minus e raised to 0. That is equal to limit a tends to infinity minus e raised to minus a plus 1. That is equal to a tends to infinity, e raised to minus a is tends to 0. Limit a tends to infinity minus 1 by e raised to a plus 1. A tends to infinity, e raised to a goes to infinity, 1 by infinity goes to 0. So 0 plus 1. So you got this integral 0 to infinity 1 by e raised to x dx is 1. It is a finite. Therefore, integral 0 to infinity e raised to 1 by e raised to x dx is convergent. Hence, our larger integral g of x is convergent. Therefore, smaller integral is obviously convergent. Hence, integral 0 to infinity 1 by e raised to x plus 1 dx is convergent. Okay.